Newton stated that all bodies in the universe attract each other using the force of gravity. This force of gravity is directly proportional to the product of the two masses and inversely proportional to the square of the distance between them. So let's say we have a body whose mass is 1 kg and it is resting upon the earth. How do we find out the force of gravitational attraction between the earth and this body? So here's a zoomed out view of the body and the earth. We will use the equation F equals to G capital M lowercase m upon r square. Here capital M is the Earth's mass, which is equal to 6 into 10 raised to 24 kg. Lowercase m is the mass of the body, in this case it's equal to 1 kg. Capital G is the universal gravitational constant, and r is the distance from the center of the earth to the center of this body. It happens to be the radius of the earth, which is equal to 6.4 into 10 raised to 6 meters. Now, when we replace all these values in this equation, we get the force of attraction between the earth and this body whose mass is 1 kg, and that is equal to 9.8 Newton. So because gravity is a force, it will cause all bodies to accelerate to the earth. So how do we find out the acceleration due to gravity? According to Newton's second law, force is equal to mass into acceleration. Therefore, the force of gravity will be equal to mass into acceleration due to gravity. In other words, F would be equal to m into g. And when m is 1 kg, we saw that the force F is equal to 9.8 Newton, which means that the acceleration due to gravity would be equal to 9.8 meters per second square. Now, we have two equations. The first one is F is equal to m into g, and the second one is F is equal to capital G mm upon d square. Now, because these two forces are the same, m into g would be equal to g mm upon d square, which means that the acceleration due to gravity g would be equal to capital G m upon d square. Now this is a very interesting equation. It gives us the relationship between the lowercase g, that is acceleration due to gravity, and the uppercase g, which is the universal gravitational constant. Now, if capital G and d are constant, the lowercase g would be directly proportional to m. Now the lowercase g is acceleration due to gravity, and that is directly proportional to the mass of a planet, which explains why the larger planets have a greater acceleration due to gravity. Pluto has a lesser mass and therefore its acceleration due to gravity is only 0.61 meter per second square, whereas Jupiter has the largest mass amongst all planets and therefore its acceleration due to gravity is as high as 26 meters per second square. Now let us look at another implication of this equation. If capital G and capital M are constant, lowercase g is inversely proportional to d square, which means that the acceleration due to gravity is inversely proportional to the square of the distance from the planet's center. Now what is the implication of this relationship for acceleration due to gravity upon the Earth? We know that the polar radius is lesser than the equatorial radius. So therefore, the acceleration due to gravity is lesser at the equator compared to the poles. Now, if we look at this equation, we find that acceleration due to gravity is independent of the mass of a body. That means that if we drop two balls of different masses from a building, in the absence of air resistance, they would come to the ground in the same amount of time. So when a body drops from a height h, its initial velocity is 0. And as it drops, its final velocity is v, and this is the velocity of the ball on just touching the ground, and that would not be equal to 0. So this is an example of motion in one dimension. So we can use the equations s is equal to v square minus u square upon 2a and s is equal to ut plus half at square. In this case, s, the displacement, is the height h, the acceleration is the acceleration due to gravity g, and of course the initial velocity is equal to 0. So therefore the equation s is equal to v square minus u square upon 2a becomes h equals to v square upon 2g, and the equation s is equal to ut plus half at square becomes h is equal to half gt square. And now the summary of this video. The force of the Earth's gravity acting upon a mass of 1 kg is 9.8 Newton. This force causes bodies to accelerate to the Earth at the rate of 9.8 meters per second square. The acceleration due to gravity is independent of the mass of a body. The acceleration due to gravity is directly proportional to the mass of a planet. The acceleration due to gravity is greater at the poles and lesser at the equator. So that's all in this video. In the next video, we will look at another interesting chapter, that is fluid pressure.